of our mathematical modeling topic. Okay, so first of all, let's revise, right, the concepts we discussed in previous sessions. We started with the basics of mathematical modeling. We understood why we do mathematical modeling, right? We have also discussed about transfer function method, right? Limitation of transfer function, what is transfer function. Then we have tried to relate mechanical system and electrical system. So if you recall, prior to the previous class, we have derived this force voltage analogy and force current analogy, right? And in the previous class, what we did, we have converted one mechanical system, right? Let me show you the same question first. Okay, we have converted the mechanical system, this mechanical system, okay, in corresponding electrical system having current source and electrical system having voltage source. Okay, so the steps are very easy. You have to just derive the differential equations first, and after deriving differential equations as per the question, here first they have asked force current and then force voltage. So you have to replace the terms from the table of force current and force voltage, and after that you have to draw corresponding electrical circuit, right? So if you recall the solution, we have understood how we can draw this nodal diagram, how we can derive these differential equations, and how we can convert them into corresponding electrical KVL and KCL equations. And after that, we have derived or we have drawn this corresponding force current analogy circuit and uh, force voltage analogy circuit. So any doubt in this, friends? Is there any difficulty? I hope you have repeated the same. Steps are very easy, right? As many number of masses are there in the system, those many number of differential equations will be there, right? And after that, what you need to do, you have to observe the system first, right? You have to see all the components, and then first of all, you have to draw the nodal diagram. And after drawing nodal diagram, you have to straight away go to write the differential equations, right? So how we can write differential equation for M1 and M2 that we have discussed last time. We have to consider all the components connected with M1 when we are writing equation for M1, and equals to F of t will be there, and there is no direct force applied on M2. So you can write equals to 0, and you have to consider direct components connected with M2 in the equation of M2. Okay, and after deriving those correct differential equations, you have to replace with corresponding terms, either for force voltage or force current, right? These were the steps, and I have also taught you the shortcut. If you are not knowing, or if you are not having correct differential equations, then also if you have drawn nodal diagram correctly, you can draw straight away force current analogy and force voltage analogy circuit. Okay, so when we are drawing force current, we are simply replacing the components. You know the table of force current. Okay, from nodal diagram, you replace simply with those components, right? And if you have force voltage, you have to convert from series to parallel, parallel to series, and then you have to draw the circuit, right? So these were the steps. Okay, so I'm expecting that all of you are clear with this example. Okay, still if you have any doubt, you don't hesitate, you can ask me, right? I'll explain, there is no issue. Okay, so let's have more practice on examples. Okay, I'm going for further examples. Okay, so let me go to other mechanical system, right? This is comparatively bigger mechanical system because you are having three masses here. Okay, and you are having one force applied on the system. Okay, before going in the solution, I have always asked you to observe the system first, right? So you read the question. What is the question here? Uh, for following translational system shown in the figure, obtain the differential equation describing it and draw the electrical network using force voltage. Okay, so here straight away we have to draw force voltage, but prior to that you have to draw nodal diagram, you have to write differential equations, And with the force voltage table, you have to do replacement, and then you have to draw corresponding force voltage circuit, right? So these are the steps. Now you have to observe the system first. So how many masses are there? M1, M2, M3, three masses. Okay, where you are applying the force, on mass M1. Okay, so in the equation of M1, you will write equals to F of t. In other two equations of M2 and M3, you don't need to write equals to F of t. It will be equals to 0 because there is no direct force applied on M2 and M3. Okay, then what are the other things you have to observe here? This is nothing but rigid support. Okay, this body is just showing you the rigid support. So this B1, B2 and B3 are nothing but frictions from the ground. Okay, they are actually damping constants. So you know how to represent them, right? Here they have just shown with the arrow, but when you are drawing corresponding nodal diagram, you have to draw with the damper symbol. Replace with damper symbol. Okay, right? So how we can draw the nodal diagram? All of you please try for a minute. I'm giving you 1 minute to draw by yourself, and then we'll understand and we'll compare with the right answer. How we can draw the nodal diagram for this? Please draw by yourself first. I taught you the steps. I told you that you have to start from the force, okay, and then you have to put masses vertically. You have to put the nodes equals to number of displacement. Here for M1 displacement is x1, for M2 displacement is x2, and for M3 displacement is x3. So you will have three nodes, and then whichever components are remaining, you have to present them in the way they are connected in the actual circuit. So for example, if K1 is connected between rigid support and M1, so you have to put in that way only. Okay, please try it once. I'm giving you some time. All of you, please try. You should take care that there should be the same connection, okay, for all the components, and you should not miss out any component. These two things you have to keep in mind. Okay, so I'm expecting that you have attempted, right? Okay, okay. Let me show you the nodal diagram, okay, and then you cross check with your attempt. So you can see here, force F of t is applied to mass M1. Okay, I taught you last time that you have to draw the common reference first, and then you have to draw the source. Then you have to put all the masses vertically. So M1 with node x1, M2 with node x2, M3 with node x3. Okay, up to this, I think all of you are clear. All of you have drawn correctly up to this. Then you have to put remaining components. So if you see here, between M1 and rigid support, friction component B1 is there. So between M1 means X1 and rigid support, you have B1. Same way, between M1 and rigid support, you have spring K1. So you can see here spring K1. I hope I'm making you understand this clearly. This K1 came from this K1, right? Okay. After that, if you see between M1 and M2 means X1 and X2, you have B2. B2 means this B2 came from this friction coming between two masses. Okay, right? Now you go further. You have node x2 here, right? Between node x2 and rigid support, you have spring K3. So between node x2 and rigid support, we can put spring K3. You can also show like this. There is no problem. Huh? In the book, they have shown like this for just simple representation, but you can also show like this. There is no problem. Okay. Now between x2 and x3, there is a spring K2. You can see here between x2 and x3, you have spring K2. So it is shown here. And then between rigid support and M3 means X3, you are having damper B3. So rigid support is this and X3 is this. In between, you have damping factor, that is B3. I hope the nodal diagram is correct with your answer. It's matching. This nodal diagram will help us to straight away draw the circuit with shortcut, right? Whatever question is asked for force voltage or force current, right? If you have force current, simply replace the components with corresponding component from the table. And if you have force voltage, you have to convert from series to parallel, parallel to series, and then you have to replace the components, right? So that's why we are drawing this nodal diagram. I have also taught you the shortcut. Any query, students, in this figure? Any query in this? Anyone, any difficulty? Okay, fine. So that's clear. Now let's move further. Right now, after drawing the nodal diagram, the steps are easy. You have to straight away go to write the differential equations. How many differential equations will write? How many differential equations will write? Yes, correct. We'll write three differential equations. Okay. Why three? Because there are three masses. Okay. So you have to write three differential equations. Now, when you are writing differential equation of M1, okay, can anyone help me to write the equation of M1? You can unmute and speak. Equation of M1. First of all, you write in your book and then we'll get the answer from you only. You try to write all the terms. Okay. How we write the equation? We have to consider all the components connected with M1. Okay. And force is directly applied on M1. So we'll write equals to F of T. Okay. Fine. Yeah. I want the answer from your side. Anyone, please try. Equation of M1. I am waiting for a reply. You try. If you are wrong, I'll help you. No worries. Okay. At least you try. It's simple. F of T equals to M1 X1 double dot. Okay. Plus B1 X1 dot plus K1 X1 plus B2 X1 dot minus X2 dot. I hope all the components are covered. Anything is missing? Is it right? Okay, fine. Now how we can write the equation of M2? M2 का इक्वेशन कैसे लिखेंगे? Please you try. I want someone to speak. M2 का इक्वेशन कैसे लिखोगे आप?
Sir, is it K3 x2 plus M2 x2 double dash plus B2 x2 minus x1 equals to 0?
K3 x2 plus M2 x2 double dot plus K2 into x2 minus x3 plus B2 x2 dot minus x1 dot equals to 0. That is right. Good. I hope all of you are clear. Okay, how we write the equation of M3? Someone please speak. M3. It is smallest equation. M3.
Sir, is it M3 x3 dash B3 x3 dash plus K2
Just a
into
minute.
x3 minus x2?
Dishant, please wait. M3 x3 double dot or double dash.
Yes, sir, double dot. Sorry.
Yeah. You please repeat.
M3 x3 double dot plus B3 x3 dot plus K2 into x3 minus x2 equals to 0.
Very good. Perfect. Okay. No other compounds will come. Only this B3 and K2 will come when we write the equation of M3 because they are directly connected. So remaining compounds you don't need to consider when you're writing the equation of M3. So it's very easy. M3 x3 double dot plus B3 x3 dot plus K2 into x3 minus x2 equals to 0. Is it clear, friends? Or shall I repeat any equation? All of you are clear? Differential equation should be correct. Then only after deriving right differential equation, you can go ahead with replacement. Okay, if you're missing any term here, you will not be able to get the correct equations. So let's check the equations which we have derived with the solution. So first equation m1 x1 double dot plus b1 x1 dot plus b2 into x1 dot minus x2 dot plus k1 x1 equals to f of t. Right, first equation we have already derived. Second equation m2 x2 double dot plus b2 into x2 dot minus x1 dot plus k3 x2 plus k2 into x2 minus x3 equals to 0. And when we are writing the equation of M3, F3 x3 double dot plus B3 x3 dot plus K2 into x3 minus x2 equals to 0. So these are my equation 1, 2 and 3. Any difficulty, students? Any doubt in this equation? All three equations? It's easy, right? Now we are in the second example, so it's very easy. You know the steps. You also know the further steps. Okay, fine. Now in the question, what they've asked force voltage. Draw force voltage analogy for given system. Okay, we have to draw force voltage. So what we do for force voltage? This first step is common, right? First step is common. We have to write differential equation. Then we have to see which conversion we have to do. Here we have to do force voltage. So simply you do the replacement with force voltage. You know the table F to V, M to L, B to R, K to 1 by C, X to Q, and X dot to I. I hope you recall this. Okay, so simple up replacement kar do, and when you do the replacement, you will get equation 4 and 5. Wherever you find Q1 dot, Q2 dot, you can put I1, I2. Okay, because I is dq by dt. Any doubt, students? Equation 4 and 5. Yes, it is easy, right? Now in the next step, what we do? We simply q double dot is di by dt. Okay, and if after replacement you will get this, you just simply put q double dot is equals to di by dt. Okay, or q is equals to integration I dt. And if you do the replacement, you'll get equation 7 and equation 8, because we want the final equation in terms of v and I. So that's why we are doing this replacement. And then we are able to get this equation 9, 8, 9, and 10. Sorry, 7, 8, and 9. Any query, students, in this equations? Okay, now further steps are easy. Okay, if you have drawn the nodal diagram, then you have to draw the final circuit either with shortcut or through the equations you have derived. Okay, so if we go back to our nodal diagram, let me show you the nodal diagram again. This is a nodal diagram for actual system. So we actually want to draw force voltage. So we have to replace series to parallel, parallel to series. Fine. So here, if you see from the source, these three components are in parallel. Okay, so this three will come in series. Okay. Then, or else you can also remember horizontal to vertical, vertical to horizontal. It is also easy. Okay. Then this component will be in vertical position. Then these two are again in parallel, so it will come in series. Then this is in horizontal condition, it will come in vertical position. And then you have two components in parallel, they will come in series. Okay. You have to do simple replacement. For K, you need to write C. 1 by C actually, but you will write C1 in bracket, you will write 1 by K1. Okay, if you recall. For M1, what you will write? L1. Okay, for B1, what you will write? R1. Same way for B2, R2. M2, L2. K3, 1 by C3. Or C3 into bracket 1 by K3. K2, 1 by C2. Okay, M3, L3, B3, R3. And X1, X2, X3 are nothing but my, if you do replacement with force voltage, they are nothing but x1 is q1, x2 is q2, and x3 is q3. But we replace with x1 dot, x2 dot, and x3 dot. So I1, I2, I3 will be there in three loops. Okay, so let's check the actual converted circuit. Okay, so those three components were in series, right? So now we have connected them in parallel. Okay, you can see here corresponding replacement we have done, and we have connected them in series. Parallel थे वो series कर दिया हमने यहाँ पे. फिर वो जो component horizontal था उसको vertical कर दिया. Then two were in parallel, so they we have connected in series. Then again we have done that horizontal to vertical, and then two components were in parallel, so we have connected in series. And we have a voltage source in the circuit. Okay, so this is the corresponding electrical circuit for force voltage. Any query, students? Any doubt?
No, sir.
I hope everyone is clear. If you check with the circuit also, or the equations also, okay, you check the first equation. If you check this KVL, V of t equals to, this is voltage through R1. Okay, so you can see here there is R1. Okay, this is R1. Then voltage through capacitor, 1 upon say integration IDT. The capacitor is here. Actually, this representation is wrong. Okay, they have done wrong labeling. This is C1 and this is R1. Okay, then what is the current through voltage through inductor? LdI by dt. So inductor is there. Okay, then you can see here through R2, I1 and I2 both are flowing, so I1 minus I2. So this first loop equation, KVL equation, you can match. Second KVL equation, if you check, so L2 di2 by dt plus 1 upon C3 integration I2 dt plus 1 upon C2 integration I2 minus I3 dt. Okay, plus R2 into I2 minus I1 equals to 0. So that second equation also you can check with the second loop. And if you write KVL equation here, L3 di3 by dt plus R3 into I3, okay, plus 1 upon C2 integration I3 minus I2 equals to 0. I hope you can also understand this equation. Okay, you can cross check with your circuit these three equations. Is it clear, friends? All of you are clear? Direct shortcut or from the circuit? Okay, both ways we have checked. Okay, fine, great. So let's, in the question, they only asked force voltage, right? But if they have asked force current, okay. So then what from where we have to change the steps? If they have asked force current instead of force voltage. From here, right, we'll be changing the steps. We'll be having here force voltage replacement, force or current replacement. Okay, all the tables, all the components you have to replace in your circuit, and your new equations will be there, right, for force current. And after those two equations, what you will do, you will write x equals to phi. So d phi by dt is nothing but v. Okay, and then you have to derive the further equations. Okay, and in your circuit, the drawing is very simple. You have to simply replace the components, right? So force current is comparatively easy if you have correctly drawn the nodal diagram. Okay, so I have also explained the other uh, representation with current source. Okay, fine. I hope all of you are with me. You all are understanding. Okay, okay, fine. So let's move to some more examples. Now this example will solve verbally. Quickly we'll solve it. We have another mechanical system. मैं थोड़ा कॉम्प्लेक्स क्वेश्चंस आपको स्ट्रेट अवे बता रहा हूँ, राइट? सो इन बुक्स यू विल फाइंड मोर, यू विल हैव मोर एग्जांपल्स. स्ट्रेट अवे आई हैव गॉन टू 37 प्रॉब्लम. In between there are many mechanical systems, so you can solve, but these are having more complexity, so that's why I have straight away taken them for reference in the discussion, as a form of discussion in the lecture. Okay, so for the following translational mechanical system shown in the figure, write the differential equation and obtain electrical circuit based on force current analogy and force voltage analogy. Okay, both the representation you have to do. Now, before going in the solution, you just observe the system first. You can see here force F2 is applied on mass M1 through spring K1, not directly. Okay, so and in between M1 and M2 there is friction B1. Okay, displacement of M1 is X1, displacement of M2 is X2, and between M2 and rigid support there is friction B2. And this mass M2 is also connected with spring K2 to rigid support. Okay, this is the observation from the given mechanical system. Okay, all of you please try the nodal diagram. I'm giving you a few minutes, you please try nodal diagram. Okay, friends. So let's check the nodal diagram. So see, you can also draw in this way. In this example, force is applied from right side. Okay, so that's why the source is shown here. Okay, f of t, node x3, node x1, in between there is spring k2, right? After that, you're applying straight away force to this m1 through spring k1. So m1 placed vertically, m2 placed vertically. In between x1 and x2, you have damper b1. Between x2 and the ground, you have damper b2. Okay, and between ground and node x2, you have spring k2. Right, so if you just check again, cross check with the actual figure. Okay, right, all the connections are as per the given system. So this is the nodal diagram for given mechanical system. Any query, students, in this? Any doubt? Okay, now the steps are pretty straightforward. You can simply write differential equations first. Okay, when you write the differential equation of mass m1, which steps you have to keep in mind, which points you have to consider. So when we are writing for m1, what we will write? m1 this x1 double dot plus k1 into x1 minus x3. Okay, plus b1 x1 b1 x1 minus x2 dot. Okay, because b1 is connected between x1 and x2, if you see here. Okay, right, b1 x1 dot minus x2 dot. Okay, or x1, you can write d by dx of in bracket x1 minus x2, d by dt of. Okay, so it will be x1 dot minus x2 dot, but you are not applying force directly to m1, so that's why we are writing equals to 0. Okay, यहाँ पे हम क्या करेंगे, डायरेक्ट फोर्स m1 पे अप्लाई नहीं कर रहे, थ्रू स्प्रिंग अप्लाई कर रहे. Okay, so we'll write equals to 0. अभी यहाँ पे एक मैं और आपको एडवांस स्टेप बता रहा हूँ. देखो, एज मेनी नंबर ऑफ मासेस अगर आप लिखोगे डिफरेंशियल इक्वेशन, then you will only write two equations here. But actual rule is you write differential equation as many number of nodes are there. Means as many number of displacements are there. Okay, so you correct that rule. In few examples, you may not have straight away force applied to mass. Okay, so in every case, if you apply this rule, when we have number of displacements is equals to number of differential equations, then you will be having right answer in all the cases. Okay, so in few limited cases when you have force not directly applied to the mass, you have force applied to spring or damper, then also your answer will be correct. Okay, so you please note down this thing. Number of differential equations is equals to number of displacements. Okay, in the previous examples, what was the case? In number of masses equals to number of displacements for the. Okay, so here we are not applying force directly to the mass, we are applying force through spring. That's why here displacements are more compared to masses. Okay, so number of displacements is many number of equations you need to write. Okay, so this thing you need to just consider. Okay, when you solve the problem. So if you write the equation for say f of t किस पे apply किया है, spring पे. और spring जो है that is spring k1 and it is between x3 and x1. So k3 into x3 minus x1 equals to f of t. This is my first equation. Then m1 equation already we have discussed. And if you are writing m2 equation, so m2 x2 double dot plus b2 into x2 dot. Here it should be dot. Okay, b2 x2 dot plus k2 into x2. Okay, plus b1 is also there. b1 into x2 dot minus x1 dot equals to 0. So these are my three equations. Is it clear? These three equations are clear. Any doubt, anyone? Okay, now the steps are easy. Okay, if they have asked force current, you use the replacement with force current. Right, so हम force current का replacement कर देंगे from the table and you will get this further equations. Okay, right, so this 7, 8 and 9 equations are straight away after replacement, and this is basically force current replacement. Okay, so this is very easy because you have to simply replace the components in the nodal diagram. So आप simple nodal diagram में वापस चले जाओ and you replace spring K with capacitor. Sorry, it is force current. So spring K with inductance. Okay, 1 by L, right? M with C, B with 1 by R. Again here B2, 1 by R2, M2, C2. Okay, K2, L2, or 1 by L2. Okay, to be more precise, 1 by L2. Okay, so if you simply draw this diagram with electrical corresponding electrical components, you will get this circuit. This is my force current representation. Is it clear, students? Actually, it is very easy. If you solve 2-3 problems, then you will be confident. Okay, and then you have to repeat the same. Any kind of a problem is given, you have to just repeat same steps. Okay, fine. Now let's move to force voltage. Again, we'll do the replacement with force voltage, right? And after replacement, what you will get? You will get this 10, 11, 12 equation. And if you further replace Q as integration IDT, or Q double dot is equals to di by dt. So after that, you will get this further equations. Okay. And if you draw the circuit, आपको ये 3 equations मिल गए 13, 14, 15, right? After those equations, if you draw the circuit, तो आपको क्या करना है? जो वहां पे मेन नोडल डायग्राम यू हैव ड्रॉन, फ्रॉम दैट यू हैव टू रिप्लेस द कंपोनेंट्स. ओके, सो सीरीज टू पैरेलल, पैरेलल टू सीरीज आपको करना है, राइट? और हॉरिजॉन्टल टू वर्टिकल, वर्टिकल टू हॉरिजॉन्टल. तो सिंपल आप देख सकते हैं कि मैंने वोल्टेज सोर्स अप्लाई किया है स्प्रिंग के ऊपर. इन दैट एक्चुअल फिगर आई एम अप्लाइंग फोर्स ऑन द स्प्रिंग. So here volt V of t applied on capacitor, which is having value as C1, okay, which came from 1 by K1. Okay, then there is a mass, okay, M1. So we are writing L1 for M1. Okay, then if you see, these three were in parallel. Okay, in actual circuit, if you see, let me go back to that circuit. Yeah, these three are in parallel. Okay, if you see the force current also, then it is fine. Or else you go to the actual nodal diagram, you will find these three are in parallel. Okay, these three components are in parallel. I'm talking about this thing. So when you draw force current, what you will draw? You will draw them in series. Okay, this will come in vertical pattern. Okay, very simple. And if you just do that replacement, you'll be able to get this corresponding electrical circuit having voltage source. Right, so in the third loop, you will have current I3. Here there will be current I1, and here there will be current I2. You can also cross check with your equations, derived equations. Okay, so in this way you can draw the circuit. Any query, students? Force voltage circuit. All of you are through with the steps, methodology, drawing circuit, everything is clear. Okay, great. So let's see the last example of this pattern. For the following mechanical system shown in the figure, draw the equivalent mechanical network, which is nothing but nodal diagram. Then write the performance equations, means valence equations, and draw analogous electrical network based on force voltage. This is also very easy. You are straight away applying force on mass M1, okay, and you are applying force on mass M2. As many number of displacement, those many number of equations will write. Now I am going to the accurate statement. Okay, you have seen why I have modified the statement. Okay, so M1 and M2 two equations we will write. अभी आपको सिंपल, इसमें तो ज़्यादा कॉम्प्लेक्सिटी नहीं है. You can straight away draw the nodal diagram, right? So when you draw the nodal diagram, what you will get? Okay, force directly apply किया है M1 पे. Then M1 and M2 के बीच में there is B1. So you can find here node X1 and X2 के बीच में there is damper B1. Okay, then if you see the circuit again, okay, B2 जो है it is directly between M1 and X1 and ground. So B2 is directly between X1 and the ground. Okay, then with M2 you have spring K2, okay, X2 and ground के बीच में. So this is the corresponding nodal diagram, right? This is easy. After looking at the previous problem, the previous two problems, this one is very easy. Okay, any question, students, in this nodal diagram? Right. So how we write the differential equations? Simple. Two differential equations will come here because there are two displacements x1 and x2. Okay. So when we write the equation of x1 or mass m1, m1 x1 double dot plus b2 x1 dot plus b1 x1 dot minus x2 dot equals to f of t. This is my first equation. I hope all of you are agree with me. Okay. In the second equation, m2 x2 double dot plus k2 x2 plus b1 x2 dot minus x1 dot equals to 0. I think you are clear with the second equation as well. Okay, fine. So now the steps are clear. You have to simply replace the terms in whatever pattern you want, force voltage or force current, right? And then you have to follow the same methodology and you have to draw corresponding electrical circuit with voltage source and current source. Okay, those are further steps. You try this problem in homework. Okay, fine, right? So today we'll keep the discussion up to this point, right? And in the next class, we'll go ahead. Okay. In exam, I can also ask to derive the transfer function. For example, यहाँ पे अपने फोर्स किस पे अप्लाई किया है m1 पे, so I can ask to derive the transfer function. मैं ऐसा आपको बोल सकता हूँ कि आप x1 of s by f of s डिराइव करो. So वो सिंपल है. उसमें क्या करना है, आपको जो डिफरेंशियल इक्वेशंस दो मिले उसको सिंपल लैप्लास में कन्वर्ट करना है एंड फ्रॉम दैट यू हैव टू सब्जेक्ट x1 of s by f of s. वो क्वेश्चन बहुत सिंपल है, उसमें कोई एनालॉजी नहीं पूछा है मैंने. Okay, so I can also ask to derive the transfer function. I can ask to derive the corresponding electrical circuit. Okay, both kinds of questions are possible, right? So now you will be able to solve the third experiment also. Okay, after this session, in third experiment, only that small point is left. In the second problem, I have to explain few things. Oh, sorry, in first problem. Otherwise, all the other concepts are discussed. So you can also solve the problems in experiment number 3. Fine. So I hope the discussions which we had today was clear, right? All the points you have understood. You have practiced more example, force voltage and force current analogy, right? You repeat the same and solve the last problem. हाँ, जो मैंने लाप्लास आपको बताया, जो मैंने आपको ट्रांसफर फंक्शन डिराइव करने के लिए बोला है, उसके एग्जाम्पल नोट्स 1 में है. फॉर एग्जाम्पल आई कैन आस्क सच प्रॉब्लम्स. x1 of s by f of s डिराइव करो और x2 of s by f of s डिराइव करो. ऐसे क्वेश्चंस में पूछ सकते हो. उसमें क्या करना है, सेम मेथोडोलॉजी अप्लाई करना है. फॉर एग्जांपल मैंने नोडल डायग्राम ड्रॉ किया पहले, विच यू नो हाउ टू ड्रॉ, राइट? सो दिस फर्स्ट स्टेप इज क्लियर. देन वी राइट द डिफरेंशियल इक्वेशन. ओके, सो हमने क्या किया यहाँ पे, डिफरेंशियल इक्वेशन डिराइव किया, इक्वेशन 1 एंड इक्वेशन 2. फिर अगर मुझे x1 ऑफ s बाय f ऑफ s डिराइव करना है तो मैं क्या करूंगा, सी आई कैन आइदर गो इन द मैट्रिक्स फॉर्म. सो मैं सिंपल यहाँ पे ऐसे लिख सकता हूँ एंड आई कैन फाइंड द डिटर्मिनेंट. ओके, so transfer function क्या होगा, x1 of s by f of s. So how I can, you know this method, you have used it in circuit and networks. Okay, so x1 of s कैसे find करते हैं, x1 of s find करना है. So for x1 of s what you do, you replace this with the first column. Okay, so f of s 0 यहाँ पे replace कर दिया and second column is as it is, divided by delta. Delta क्या होता है, determinant of this matrix. That will be x1 of s divided by f of s. Okay, so f of x1 of s by f of s is a transfer function. ओके, सो सिंपल आप ये मेथड भी अप्लाई कर सकते हैं. अदरवाइज ये दो इक्वेशन है, इसका लैपलास लेके आप उसमें से यहाँ पे ऑलरेडी एफ ऑफ एस है, इस इक्वेशन से यू विल गेट x1 ऑफ s एज अ सब्जेक्ट. मैं आपको दूसरा मेथड सिखा रहा हूँ जो बुक में नहीं है, वो भी बहुत ईजी. आप ये इस इक्वेशन का लैपलास लेके x1 ऑफ s को सब्जेक्ट बना दो एंड यू ऑलरेडी हैव f ऑफ s इक्वेशन हियर. यू डिवाइड इक्वेशन 1, इक्वेशन जो आप x1 ऑफ s का इक्वेशन है उसको इक्वेशन 1 से डिवाइड कर लो. And after simplification will also get the same result, this result. Okay, either you can apply this method or you can apply straight method, okay, which is not given in the book, right? So you may have such problems also. Derive x1 of s by f of s or x2 of s by f of s for given mechanical system. Steps are straightforward. अगर इलेक्ट्रिकल सर्किट नहीं पूछा था तो बहुत इजी हो जाएगा. नोडल डायग्राम ड्रॉ करो, you write the differential equation, you take the Laplace, and then whatever transfer function x1 of s by f of s अगर करना है, x2 of s by f of s करना है, उस हिसाब से आप सब्जेक्ट बना.